Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com, and I wanted to introduce you to the Sleep Keeper. The Sleep Keeper and the portable Pico Pal are up on Kickstarter at the moment, and this is just a quick demo video that talks about the specifics about the Sleep Keeper. If you want to know more about the Pico Pal, make sure to check out the Kickstarter link below. In any case, the Sleep Keeper is Arduino based. It plugs into your computer and can be programmed and communicated with the Arduino IDE, where the Pico Pal uses MicroPython and Thonny. There's also slight differences between the two, such as this module, the Sleep Keeper, was designed more for data logging and interacting with you while you sleep. It's not a medical device by any means. It's more of a programmable device that's also educational, because if you pledge towards a campaign, you also get all the sample code that's fully commented, so you can see how I run all my programs. Currently, there's a program that stops you from snoring, and it self-calibrates. Everything is logged to an external SD card. There is a heart rate sensor on it. It plugs in right here. And there is an audio output, because there's a library of audio bytes that is played by this chip. That's also connects to an external speaker that can be put under your pillow. This is all for experimenting and writing new algorithms and thinking of new ways to interact with you if you're making too much noise at night snoring, to tell you to turn you onto your side or wake you up for a nightmare if your heart rate changes too fast. There's an onboard microphone, a temperature sensor, real-time clock, DS3231 chip, which is awesome. We use that for time-stamping data to the SD card. There's an Atmega 328P, which is what you use for your Arduino. 2 buttons, an external plug-in that can be used for a PIR sensor, or an external device is powered at 5 volts. So you can remove this and connect an external device right here, if you so wish, because the programming is all up to you. You can adjust the heart rate sensor with this variable, or this potentiometer, and there's also a light sensor right here. So we've got noise, we've got motion, we've got temperature, we've got light. We have a lot of different sensors on this unit that will really help us to data log. There's a data logging program that logs the time and date when motion or noise is detected, so you can just leave it in a room, and every time it notices motion or light, it will capture that, timestamp it to the SD card. There's a program that allows for you to plot your heart rate to the serial plotter in Arduino. There's another program, I think I already mentioned it, the Snoring program, that wakes you up. It baselines the noise in the room, and then it compares it against the new noise in the room every few seconds, and if it detects that you're consistently snoring, it will tell you you're snoring, wake up on your side, or turn onto your side. And how do you do that without waking up your partner? This tiny speaker extension goes under your pillow, if you so choose to, and instead of using the audio output for higher volume, you use a smaller amount of volume under your pillow by plugging in the speaker right here, and then this long 1.5 meter extension can go under your pillow at night, and it can wake you up potentially. Again, how you use this is up to you. It is not a medical device, but it's a fun device that will help you to kind of play with your sleep if you so wish to. Now, I don't recommend losing sleep by any means. That's very unhealthy. You need you need a lot of sleep to live a healthy life. But if you find that you're snoring and you want to play with this, I snore, and I've been playing with this, and I haven't perfected it yet. But anyway, yeah. So there's a lot of programs on the go, and there's going to be sample commented code for everything. This battery right here is for the real-time clock module, which allows for you to keep time even after you remove power, and it should last more than a year. So let's look at some of the programs. As you can see, Void Loop is currently calling several programs, most of which are commented out. Right now, I've just got a function that calls every single audio byte in the library. I'll give you a taste of that right now. So I've got powered speakers connected.
Profiling. Room noise. SD card not inserted. Power down and insert a compatible SD card. Select program. Sensor. SW1. SW2. Terminated.
I also have the option of using the external speaker, which comes on a 1.5 meter connection right here. And then I'll plug it back in. And this is for an under the pillow option, a quieter option than a set of powered speakers. I'll plug it in.
Profiling. Room noise. SD card not inserted. Power down and insert a compatible SD card.
At the end of the campaign, you'll be able to choose between Velcro or a clip for the heart rate sensor. The Velcro option comes with a long Velcro strap that you feed through the circuit board and around your finger, so you can tune it to the size of your finger. The clip option, we give you the circuit board, you solder it on, and it's glued to this clip and onto your finger, and it plugs into the board like this. My Velcro clip is now connected. If I select the Heart Plotter program, as you can see, I've opened the serial plotter, and it's plotting my heartbeat. There's a variable resistor on the board that allows for me to play with the gain, so you can actually change the gain of the signal coming from the sensor as you see fit. I'll be creating a more intuitive way to call all of these programs when the campaign is, by the time the campaign is done, but for now I'm just skipping between programs via uploading different scripts. In any case, I've got the Heart program executing right now, and if I look down at the Sleep Keeper, what it's doing is it's taking 10 samples of my heartbeat, and every 10 beats you'll see it flash blue, and that means that it's saving to SD. Just happened. So what it did, it averaged the time it took across 10 heartbeats and averaged my heart rate. So if I open the serial monitor, so every 10 seconds my heart rate is being logged to the SD card, my average heart rate. And right now it's between 76 and 82 beats per minute, and that's the average person has an average BPM of between 60 and 100. The more fit you are, the better shape you're in, the lower resting heart rate you'll have. And again, if I'm sitting down, I'll have and relaxing, my beats per minute will go down and down. If I'm sleeping, it will go down. If I'm running, it'll obviously go up. So this is just one little program, and you can see how I managed to do this. You can read my algorithm. So let's look at another program. Data Logger allows for you to choose between motion and noise capture. So if there's too much noise in a room, say someone opens a door, it'll log a timestamp. It'll also say why, on the SD card, it'll say why why there was a trigger. For instance, motion was captured. Noise was detected. You were snoring. It all depends on what program you're in. But Data Logger, this program is a little bit bigger, and it requires a video all on its own. Needless to say, it's an awesome program, but I'm going to skip that one for now, and I'm going to show you just one more program. I'm going to show you Snoring. Now, in Snoring, what happens is it instructs you to be quiet for 5 seconds, so it can get a baseline of the noise in the room. And then after that, if you make intermittent noise, nothing will happen. But if you're making a constant snoring sound, it's going to detect that, and it's going to tell you you're snoring, turn on your side. So I'll give you an example of that right now. So the Snoring program has an algorithm that deserves its own video, and it'll probably get one too. So what I'll do is I'll open the serial monitor. Hopefully you can read everything. You get your usual initialization, and it says, be quiet, calibration will begin in 3 seconds, starting calibration. Now, I'm interrupting this. I've already messed up the calibration because I'm talking during it. But now what happens is, and it's probably going to malfunction because of this, because I'm talking so loudly, is if the noise is inconsistent but constant, it's going to tell you to turn on your side because you're snoring. But if you're quiet and intermittently noisy, say I start talking for a second and then I leave the room, it's going to ignore it. There's an algorithm in place that looks for a consistent snoring. Now I've got feedback going down the page here, and it doesn't mean a lot to you, but it's part of the algorithm. So what I'm going to do is I'm going to reset this right now. I'm going to reset it. We're going to be quiet during the benchmark state, and then I'm going to turn on a snoring program. I've got my sleep video, or my snoring video ready to go. I'm going to be quiet. My baseline has been taken, 389. So it started the program. 7041. So I'm being too noisy right now. 5183 still way too noisy. But now I'm down to 95, which is under the baseline. So it goes back. So if this number underneath it goes all the way up to 4, it'll tell me to turn on my side. I've been snoring. But I'm not going to get there just yet. It always goes back to 0 if it skips one, where there wasn't consistent noise. But now I'm going up again. I'm back to 1, and it's going to go to 2. I'm going to be quiet, and it's going to go to 3.
You are snoring. Turn on your side.
And then afterwards it logs that your timestamps to the SD card that you were snoring, and it gave the date and time. And yeah, so now I can check out the SD card, and that will be there. I'm just going to stop this video right now because it's annoying. I've actually removed the Sleep Keeper. I've removed power, so it's no longer functioning. Yeah, so that program is going to be really nicely tuned by the time this campaign ends. There's going to be another protocol that I designed that's going to monitor your heart, and if you get a spike in your heart rate while you're sleeping, it will say you're having a nightmare. Now, again, this is not a medical device. It's basically a device that you can experiment with and really create projects and algorithms that are your own. So there's still a lot to show you on this board, but that's a good demo of just getting started. Before we stop the video, I'll remove the SD card, I'll throw it in an SD card adapter, plug it in my computer, and we'll see what was logged. So these are all my timestamp logs. I can delete them. You have to create a text file called SD test and place it on the SD card. Easy peasy. The computer or the Arduino does the rest. The Sleep Keeper does the rest. And right now it is my last log is at May 6th, 2021, Thursday, 15:34, which is 3:34 p.m. It's now 3:35. Reason for log: you were snoring. And it tells me the light level, which is 413, and the temperature, which is 23.75 degrees C. So that's it. A very quick look at the Sleep Keeper as it currently exists. There will be plenty of videos, lots of commented code, and lots of encouragement to make this your own. Create your own programs, program them in the Arduino IDE, and there'll be a full functional video at the end of this campaign showing you how to set everything up, how to download the driver for the CH340G USB bridge, everything you're going to need. Tons of commented code. So yeah, thanks for watching. Sorry if this video dragged on a little bit. I wanted to get a little bit of everything in it. So take care of yourselves. Thanks again.